Today we will go over section 4.1, which is increasing and decreasing functions. So in order to understand if a given function is increasing or decreasing, we need to learn to interpret the graph of the functions given to us. So for example, in this parabola given in the graph, if I were to start from the left side for x value, so if I start from here somewhere and go to the right, so because the function is given, I would start from the left and start going to the right? So I follow the function I draw on it. So I can see that left side of the graph, where x is smaller than 0, starts to decrease, right? I go down, so it actually starts decreasing. While the right side, right side meaning when x is bigger than 0, starts to increase, right? But I can actually confirm this analysis via the definition given to me from my textbook. So we say that a function f is decreasing on an interval if for any value of x1 being smaller than x2, my fx1, which is my y1, is bigger than my y2. So just to deliberate more on that, if I said my x1 is -2, so let's say I chose this as my -1, right? Because my x1 needs to be smaller than x2, and let's say my x2 is my -1. That's my x2, right? So I satisfy the condition where my x1 is smaller than x2. Now I need to look at the y value. So I know for fx1, I would get a value right over here because that's what corresponds to my x1, so a value of 4. And I know for fx2, if I plug in my y value, corresponds to right over here, which is 1. So now I look at both of the y's. I know my fx1 is 4, while my fx2 is 1. So now, because this is bigger than my fx2, I can say my function is decreasing. Now, similarly, we say that a function is increasing on an interval if for any value, so x1 is still smaller than x2, so I keep that the same, but now my y is smaller than my y2, so fx2. So because this portion is increasing, let's say my x1 was over here and my x2 is now no, x2, yeah, so x2 is my 2. The y value corresponding to my x1 is 1 again, and the y value corresponding to my x2 is at 4, right? And I know my fx1 has a value of 1 now instead of 4, and for the value of x2 given over here, I have a value of 4, and I know 4 is bigger than 1, therefore my function is increasing. So another way we can examine is by drawing a tangent anywhere on the parabola and observe their slopes. So if the slope is negative, then the function is decreasing, such as the tangents drawn over here when it's smaller, x is smaller than 0. I see that the slope of these would be negative. Whereas the same thing over here, I know the slope for this would be positive, therefore it's increasing. But how do we get the slope of the tangent if, let's say, I didn't have this graph? Well, you can use derivatives. We have been using this whole time to determine that. So let's say I had only the function of y equals x squared, right? I can take the derivative of it and find that it is 2x, and I can test it with a value of when x is smaller than 0, which is a negative value. So let's say I was to plug in -3, my answer would be negative. So this negative value would indicate that my function is in fact decreasing. Also, remember that this is applicable to both continuous and differentiable function. So let's get used to drawing a graph with instructions given. So for this one, it wants us to sketch a graph of a function that is differentiable, so no holes, nothing. We did this before in the previous sections, on the interval -2 to 5 that satisfies the following conditions. The very first thing I do before even reading anything, just to make sure, is I'm gonna put my intervals. So let's say I put -2 over here, here's my -1, and 1, 2, 3, 4, 5. And here's my 5. I know it's going to be between, so I'm just getting used to it. The first instruction is, let me use a different color. The graph of f passes through the points -1 to 0. So -1 and 0 is this point, right? Because this is my -1 for x and 0 for y. And 2 when x is 2 and y is 5. So I'm going to also draw 1, 2, 3, 4, 5. So here's my 5, and I'm gonna say 2 to 5, which is right over here. So I know my graph, when I'm drawing it, it has to go through those. The function f is decreasing on -2 to -1. So I know that it's going to start from -2 somewhere. Doesn't matter where, because they don't give us any function whatsoever. And I'll just go down, because we go from like left and right, and because it goes from -2 and to -1, for it to be decreasing, it needs to be go down like that, just like the previous parabola we saw. Increasing on -1 to 2. So I know -1 and 2 is right over here. I have to increase, but also I know at x equals 2, I have to go through that point. So I can basically connect those 2 points, but increasingly, and that's kind of the only way to connect those two, unless there's another instruction. And I know it decreases again from 2 to 5. So I know from here I'm gonna come until x equals 5, so like at 5 point. I cannot end here, I cannot end here, it has to go until 5. But I know it decreases, it doesn't matter how you do it, but it's just something like that, and that would be my graph, because they don't tell me anything else. So this question is similar to the last one, it's just the derivatives are integrated now. So sketch a graph of function f that is differentiable, so no holes, nothing again, and no discontinuity, and that satisfy the following conditions. Now when I look at these conditions, the first thing I do when I sketch the graphs is start with the simplest one, or that like start with the point ones. So point 1 is what I mean, like when x is 2, my y is 5, stuff like that. So you have an idea of the points. So if we start with that, I'll start with the simplest, which seems like the last condition, which says when you actually have x as -5, you get the y value of 6. Also be careful that there's a derivative prime sign over here, and there is not. So when x is -5, the y value I would get 6, but it cannot be the derivative of it. So I'll say here is my -5, right? And I'll say here is my 6. And I know my function includes a point right over here. The second one it says is when x equals 1, my y is 2. So same thing, I'll put my 1 over here and I'll put my 2 over here. So I get a point right here. So I satisfied this condition now. The second one it's saying is I'll start with the first one, right? It's saying the derivative is positive when I have like smaller than -5. So I know in this region, so not including -5, in this region, I will have a function that is increasing because the derivative is positive. So what that would give me is I'll start with anywhere because I don't have the function, but I know it's just increasing to that point and I need to pass by that point, right? So I also satisfied this first one. The second one, now that I'm at the point -5, I realize that it also gives us what the derivative of -5 is. It equals 0. So we know when we take the derivative of something and it equals 0, it's either a maximum or minimum point where the tangent is horizontal. So I know my tangent, slope of my tangent is 0, right? So up here, because I tried to draw that straight, that is going to be my maximum point where I'll kind of draw this like curve like structure. And I'll go with the next one. I'll do this later on because I'm waiting for my graph to come to x equals 1. So the next option before I dive into that one is it's saying my function is decreasing, so my derivative is negative when it's between -5 and 1, and that's exactly what I needed. So from -5 to 1, I'll just have my function decreasing because my derivative is negative. So I'll have something like that, and I know it goes to that point at 1, right? So I also satisfied this condition. Now I came to x equals 1. I know the derivative equals to 0. So the next thing is, I don't know if it's a minimum or maximum at this point, but I know I'll kind of have this curve-like structure. And it also says my derivative is negative when x is bigger than 1. So from 1 and onwards, I also have function decreasing. So knowing that I have my derivative as 0 at 1, it will just go something like this, right? And I can put the arrow for this one too. So I satisfied, let me erase everything. So I did satisfy this and I satisfied this, so we're technically done. So now with this question, it says each of the following graphs represents the derivative function. So they're not the functions we're going to identify like increasing, decreasing, they're the derivative of the function I have. So it wants me to determine first the intervals where my function is increasing, intervals where the function is decreasing, as well as the x-coordinate for all local extrema. So for this, don't confuse that it's not asking the intervals where your derivative of the function is increasing, it's asking where the function is increasing. So starting with A, the first thing I do is I look for points where my y equals 0, because that would be automatically your local extrema. Because I know when my derivative equals 0 is where my extremas are. So when I look at the graph A, I know the y is 0 at this point. So I know automatically what 3 is. So I can automatically say for 3, my local extrema would occur at point x equaling to 4. So now to find if it's increasing or decreasing, you might say from previously, oh, I can see that this is decreasing and it keeps decreasing. But that's not really the case for derivatives. So the easiest way to determine is if you were to plug in something. So if you were to plug in 2, let's say as x, your y value would be 1, right? And if you were to plug in -2, you find that your y value is high, which is at 3, right? So I see that my y value increases, and as my function, the derivative has a positive value in the first place and is increasing, I know from x equals 4 and onwards to the negative side, it's actually increasing. So for my first one, where it's asking where the function increases, is when it's smaller than 4. So x smaller than 4, not equaling 4, because I know at x equals 4, I have my local extrema. So as for decreasing, I know that right over here, like if I do the same thing, so let's say at, I don't know, like at 5, which would occur over here, I have -1, and because this keeps decreasing, at like 6 I would have a lower value. So I know that my y value decreases and it's at negative, therefore it's decreasing. Having derivative as negative makes it decreasing. So I know from x equals 4 and onwards to the positive side is actually decreasing. So I will say for 2 when it's bigger than 4. It also says, assuming when you plug in 0, your y value is 2, make a rough sketch for the graph of the function. So I know when x equals 0 and I have the y value of 2, which I'll just put it right over here. And I know I have a point right here. I also know now that from my function, when x equals 4, I have a local extrema somewhere. Now I can start with the first one. When it's smaller than 4, my function is increasing. So I know I start from somewhere, right? I'll just put an arrow. I pass by this point and I go until 4. At 4, I have my local extrema, right? And from 4, when it's bigger than 4, I know it's decreasing. Therefore, it's going to go something like this. So that would be my function. So another one I'll do is B, and C and D, I'll just put the answers into the video and you guys can try. So for B, as I said, let's start with where the derivative is 0. Derivative is 0, I look at the graph for B right over here. When y equals 0 is this point, so is this point and this point. And I know this point corresponds to -1 and 1 over here. Therefore, for my 3, where we have the local extrema, it's x equaling to -1 and x equaling to 1. So it's not 1 point now, it's 2 points. So as for where it is increasing, I'll start from the left side actually and analyze it, not just show the increasing sides. So I take my local extremas as my points where I'll differentiate. So from -1 and onwards, so I'll just look at the portion over here. I realize that, let's say when I plug in -2, which corresponds to right over here, I have the value of y value of 3. Same thing, I try for -3, right? And when I do that, I know I'll get a higher value because this keeps going up. So I'll get a higher y value. That means whenever I try to go for a bigger negative value, I'll get a bigger y value, which is positive. So because my derivative is positive and it keeps increasing, therefore my function is increasing. So I can say for 1 and 2, so where 1 is increasing, I can say when x is smaller than -1, my function is increasing. So that's 1. So the next portion is right over here I'll start with. So I'll divide it into 2 and then we have to put them together at the end. So right over here, starting from -1, x equals -1, if you, let's say, were to plug in 0.75 and you'll get the value of something which is right over here, which is smaller, right? But when you decrease it, as to 0.25, you get a higher negative value. So basically, when you go up to x equaling to 0, which is right over here, that's why I divided it into this section first. So from x -1 to x 0, I know the function is decreasing because my negative value is increasing for the derivative. So I get higher negative values as I approach x equals 0. So my function is decreasing. So I can just say for now, between -1 and 0, let's say, I'll just say that it's decreasing. So that's why I put it to 2. So now that I know my local extrema is located right over here, I also need to figure out what happens right over here, as, let's say, is it approaching to x equals 0, or it's approaching to the local extrema. So if you were to start with x equal to 0 and look if it's increasing or decreasing from here, you'll know you get a value where your negative is decreasing, right? So you might say, oh yeah, this is increasing in fact, right? But I can basically start from the local extrema and go down from there to get the same exact response and connect it to 0, right? So if I were to do that, my function is decreasing again. I would say between 0 and 1, my function is decreasing. And what I realized over here, when you have zeros, you can actually put them together to have a value where the function is decreasing. So when you put the zeros together, all you need to do is saying, because they cancel each other out, saying when x is smaller, bigger than -1, my function is decreasing. Also, when it's smaller than 1, it's decreasing. So now I actually have something to put for decreasing, like together. Now, starting from the local extrema, which is at x equals 1, I look at over here. I see that when I have 2, I'll get a value like probably something around here. Let me erase that, I drew it twice. So something, yeah, so I get the value of 3. And let's say I increase my x value to 3, I get a bigger value. So that just tells me I get a higher positive value for the derivative, which shows me that my function is in fact increasing. So starting from x1 and going onwards, I can say when x is bigger than 1, my function is increasing. So now when I start sketching, like I said, I'll start with the points given first. So x equaling to -1, I'll just put it right over here, and x equaling to 1. And I know when x is 0, my value is 2, which I'll put it like over here. And I know I have a point here. So I'll start from the left side when I have a value smaller than -1. And I see what happens when it's smaller than -1 is my function is increasing. So I'll start from somewhere and just go up, right? And I know at x equaling -1, I have a local extrema, so I'll probably a maximum. So all I need to do is look at what happens next. So what happens next is it's between -1 and 1. I know that between -1 and 1, my function is in fact decreasing. But I also know it needs to pass through this, so when I'm decreasing, I'll actually pass through that too and keep decreasing, right? So now that I have what's happening in between, and remember this point is also a local extrema, because it going down is probably a minimum, right? And I just need to see what happens after 1. So I know after 1 my function is increasing again, so all I need to do is make that minimum and just keep increasing. So that's the sketch I would have. So this would be the answer for section C also. So I'll just leave it for a couple of seconds and pass on to the answer of D. And this is the answer for section D. In this question it says, find constants a, b, and c such that the graph of fx will increase to the point -3 and 18, decrease to the point 1, -14, and then continue increasing. So the first thing I realize is what it wants from me is to find the constants a, b, and c. And the function given is right over here. And I know it, if I were to just draw it as in like a graph, I don't know the function, but I know the point -3, if I say this is -3 to 18 occurs here, right? And I know the point 1 to -14 occurs right over here. And it says my function will increase to the point over here. So I know a function like rises right up here. And then it decreases. Because it changes suddenly from increasing to decreasing, I know this is going to be my maximum point, and I will decrease from here until that point probably and connect there. But then it says once you come to this point, it starts to increase again. So because it switches again, I can say this is my minimum and then it goes up again. So that will be my function. So the first thing I realized is that this is a maximum point and that is a minimum point. And I know those are local extremas. So basically what I can do is take the derivative of my function and see, plug in -3 and equaling to 0 and see what I get as a function for A, B, and C. So me taking the derivative, I know I'm applying power rule to this one, so bring the power to the front and -1 to the power. Over here, I'm going to do plus, apply power rule to here, and I know A is a constant, so it will just stay there. All you need to do is apply the power rule to the x squared, so bring 2 to the front, keep the constant the same because I don't know what constant it is, and do -1 to the power, so I get 2ax. Same thing over here, keep the constant and do power rule to the x to the power of 1, which will just give you 1, so you have plus b. So I got my derivative and I know this one is just going to become 0 because it's just a constant, right? So all I'm going to do is equal this to 0, but then I'm going to plug in -3 to eliminate something. So now that I plug in -3 and equal it to 0, because I know at that point at -3 my slope of my tangent is going to be 0. So from here I got 27 minus 6a plus b. I can send that 27 to the other side, doesn't matter. So I'm just going to say minus 6a plus b equals -27. So that's one of my functions that I got. Now I'm going to do the same thing to the other point, to my minimum. So I'll just plug in to the derivative of 1a equal to 0. As a result, I get 3 plus 2a plus b, and I'm just going to send that 3 to the other side to get 2a plus b equal to -3, and that's my other function. Now that I have my two functions, I just need to cancel one thing so I can find the other. The easiest way to cancel is I see that I can cancel b's very easily because it's just b to b. I don't need to multiply by 2, 3, whatsoever. I can only multiply this by negative and that will be enough to cancel it out. So when I do that, I'm going to cancel the b's and add the other one. So when I add it, I get 8a equaling to 24. And now I'm going to divide each side by 8, so I get a value of 34a. So I found my first letter. So from here, what I'm going to do is I can actually plug in a equaling to 3 to one of these functions, doesn't matter. I know the easiest function for me is 2a because 6a is just a bigger number, so we can just start with the easiest one. So now I'm going to do is I'm going to plug in 3 for my a, which will give me 2 times 3 plus b equaling to -3. Now all I need to do is send this, which is a 6, to the other side as negative. So when I do that, I get b equaling to -9. So that's my other letter. So I'm not done. I still need to find the value of c. So I know I cannot use the derivative because there is no c value there. All I can do is use this function and plug the values in there. So right now what I have for my function itself is x cubed plus 3x squared minus 9x and a plus c. But what am I going to equal to, right? I already have the y values for any of these points. The easiest one for me is to use the 1 value because you don't need to multiply or find the cube or squared of -3. It's just 1 is the easiest. So I'm just going to choose this to plug into my function and equal it to -14, which is the y value. So from here, when I plug in 1 and equal to -4, I get the value 1 plus 3, -9, which will just give me -5, and then plus c equaling to -14. I'm going to send that -5 to the other side as positive, so that would just give me -9. So I found all of my values as an answer. If you have any questions or problems you would like us to solve, make sure you go to our website and to our forum section where you can ask any of your problems.